Howdy guys, this is part 2 of your systems of equations solving by the substitution method. So the other day we were looking at if two equations were equal to each other, like y equals 3x plus 5 and y equals negative 2x minus 2. So y equals two different, they're not values, but two different expressions. So you could set those expressions equal to each other, solve for x, and then find the y. Today, we're going to look at something a little bit different. So we're going to look at what is happening if I could go to it, goodness. Here we go. All right, if we have two equations that are not equal to each other. So here we have 2y equals x plus 7, and then x equals y minus 4. So these two equations are not equal to each other. And the way I know that is because one of them is equal to 2y and one of them is equal to x. Well, those aren't the same thing. Okay, so the first thing you want to do with the substitution method is you need to solve for one of the variables. So either solve for x or solve for y. And when I am looking at maybe what would be the easiest to solve for, I can actually see that this equation on the bottom is already solved for x. X is by itself, x is isolated. Therefore, step 1 is already done for me. So I'm not sure what the value of x is, but I know that y minus 4 is the same thing. Okay, so I know y minus 4 is the same thing. So I can go back to the other equation, and instead of x in that equation, I can plug in y minus 4 because that's the same thing. So this is pretty similar to what we were doing the other day, except this time the equations are not equal to each other. So it's setting it up just a little tiny bit differently. So x is y minus 4, but then we also have to add in the plus 7. Okay, so I see some simplifying I can do. 2y equals y, and then a minus 4 plus 7 is going to be plus 3. Okay, my whole idea is to get the variables on one side and the constants on the other. So I have a y on the right. I'm going to move it over to the left because I always say the letter on the left, the variable on the left. So I'm going to subtract that y. If it helps, put a 1 in front of the y. So there's one y there. I want to subtract or get rid of that. But if I do it on one side, I have to do it on the other. Okay, and I ran out of room there, but 2y minus 1y is 1y. Your y and one negative y cancel out, and you're left with 3. And we know 1y is the same as just y, so y is 3. Okay, so now that we found y, we can find x. So when I'm looking here, I could plug in this y value into either equation and solve for x, but I'm going to use the second one because x is already by itself. If that's what I'm having to solve for, wouldn't it be much easier if it's already isolated and already by itself? And the answer is yes. Okay, but if you didn't see that, that's hard for you to see. You could plug that y value of 3 into either equation, solve for the x, and you'll get the same answer. It doesn't matter. Okay, so instead of y, I'm going to plug in 3. And then 3 minus 4 is a negative 1. Now that I have my x and my y value, I can form the ordered pair. X comes first, and then y. So our final answer is negative 1, 3. Okay, so this is, like I said, very similar to what we were doing yesterday. The only difference is this time it's not totally set up for us, or excuse me, it's not equal to each other. One of the variables is by itself. Okay, and then let's look at a couple more. So when I'm looking at this problem, I see two equations. So I'm trying to find out where these equations cross each other. What is their solution? That solution where they cross each other on the graph, but I'm going to be using the substitution method. Okay, so step one of the substitution method is to get one of the variables by itself, either the x or the y on either equation. It doesn't matter. Okay, and so when I'm looking, I see that x is already by itself in the second equation. Okay, good. Less work for me. So I can take what x is equal to. So x is equal to 5 minus y. And in the other equation, so that would be the first equation, instead of x, I could plug in 5 minus y because those are the same thing. X and 5 minus y are the same thing. Okay, and then from here, you're just trying to solve your variables. So 5, I'm going to combine like terms. Negative y, so I could put a negative 1 there if I wanted to. So a minus 1y or negative 1y minus 2y, that's going to be a negative 3y or minus 3y. So let's get that y by itself. If I have 5 of something, to get rid of it, I subtract. But if I do it on one side, I have to do it to the other. Your 5's cancel. And 8 minus 5 is 3. Now, negative 3 and y are being multiplied. I want to get rid of the negative 3, so I'm going to divide by a negative 3. Negative 3 over negative 3 is 1. And 3 over negative 3 is negative 1. And we know 1y is the same as just y. Okay? So go ahead and pause the video here and try to see if you can figure out x for yourself. And then you can come back and check. You can use either equation for x. Okay, so I'm going to just go over it. I used the second equation. I knew I was solving for x. In the second equation, x was already by itself. So I knew the y was a negative 1. You have to be really careful here because it's 5 minus. So that just comes down. And then it was a negative 1. So I put the negative 1 in parentheses. Okay. And then for those of you that know the rule, keep, change, flip. Because this looks a little funky, I can keep the first number, change my operation, and flip the sign of the second number. 5 plus 1 is 6. So these two equations will cross at 6, negative 1. Okay. I am going to skip this one. I want you to do it on your own, and then you check. All right, so go ahead and check this problem. You can see y was already isolated, so the only difference this time was the y was isolated. Okay, and then so I plugged in what y equals into the first equation, and I solved to get the x value. And then I plugged that x value into either equation. It didn't matter which one. I chose the second one because it was already, the y was already isolated by itself. Okay, so hopefully you were able to do that. All right, so I want to show you where this is going to lead to. We didn't have enough time to really go as far as in depth as we needed to, but I want to at least show you this. So this example, we have two equations, and what I can see right off the bat is that neither one of those equations have the variable all by itself. The y is not by itself or the x isn't. So all you have is an extra step. You have to get one of the equations by itself, okay? So I'm going to choose to get equation 1 by itself, and I'm going to choose to isolate the y, okay? You could choose to isolate the x, Doesn't really matter. I just think isolating the y is easier because the only thing standing in that y's way is a positive 8. So to get rid of it, I subtract 8 from both sides. 8 minus 8 cancels out. And then 2x minus 8, we can't combine those because they're not like terms. So it just stays 2x minus 8. Okay, so now that I've isolated the variable, y is by itself. Okay, so that's the only thing different about this problem. We had an extra step. We had to get the x or the y by itself first. Now that we've done that, if you rewrote that first equation like this, and then you just brought your second equation over, it's the same thing you've been doing. So now we're going to go to the second equation. So you're going to use the equation you haven't touched. And instead of y, in this equation, I can plug in 2x minus 8. Okay? And we know x is the same as 1x. 1x plus 2x is 3x. Minus 8 is 10. So we need to get the x variable by itself. I see a negative 8 or a minus 8. So to get rid of it, I add. But if I add 8 to one side, I have to add 8 to the other. I bring down my 3x. My 8's cancel, and 10 plus 8 is 18. 3 and x are being multiplied, so to get rid of the 3, I divide. If I divide one side by 3, I have to divide the other side by 3. 3 over 3 is 1, and 18 over 3 is 6. And we know 1x is the same as just x. Okay, so now I can go to either equation. Okay, you can use the first equation or the second, and if you use the first, you can use the regular format that it gave you, the original format, or the second that's in slope-intercept form. Okay, and I need to find out what the y value is. So I'm going to use the first equation, and I'm going to use it in slope-intercept form because the y is already by itself, and I know that's what I need to find. So the x, we just solved for x, and that was 6. 2 times 6 is 12. And 12 minus 8 is 4. So the solution to this system of equations is 6, 4. Okay, so basically, just to review before we stop, the very first thing we learned is when both equations had one variable isolated. So both equations had the y isolated, or we could have done one where both of them were x. Okay, and then today we added on to that, and we started doing, well, what if the equations don't look the same? They're not equal to each other, but one of the variables is isolated. How do we solve that? So we dealt with that. And then the last thing I showed you is where you really need to be able to take it for Math 1, and that is, right here, when neither equation has a variable isolated, and you have to do an extra step and rearrange the equation to get one of the variables isolated. It does not matter which variable you isolate. It could be the x or the y. Honestly, you just look at the equation and see which one seems simpler. Okay? Isolate what seems simpler, and then you solve it just the regular way. Okay?